Hello and welcome everyone to our first video on section 7.3. As you can see, it covers volumes by cylindrical shells. So this is going to be slightly different from what we did last time, where we used disk washer method. Reading this short paragraph here, we see that we'll have to use cylindrical shells when, let's say we wanted to rotate a region about a vertical axis, but we can't. Let's see if I can highlight this. But we can't easily express the function in terms of y, then we can use cylindrical shells to do that. Okay, so let's come down here to our first example. And before we actually get to the problem itself, I kind of want to show you an idea of where this is going to be coming from, this idea of cylindrical shells. So off to the side here, I'm going to draw a cylinder. So let's suppose it looks something like this. Okay, and let's suppose that it has radius r and height h. Then the surface area of this cylinder, so think like a pop can or something, is 2 pi r h. And where that comes from is really what you have is the circumference of the circle here that forms the base, which is 2 pi r, and then you're multiplying by the height. And that'll give you the surface area. So let's come over here and look at the picture that we're going to have here. So the graph of 2x squared minus x cubed, it has zeros at 0 and 2. The graph kind of goes up and then comes back down. Okay. And so what we're going to do is we're going to take this region here and spin it about the y-axis. And the y equals 0 just forms the lower part of the region here, so right there. All right, so we're going to spin this about the y-axis. So if we were using last section, what we would need to do is we would need to be able to find, and so rotating we get something like this. We would need to be able to find essentially this inner and outer washer that we're seeing here. The problem is this is a vertical axis, so everything would need to be in terms of y. And if you're going to solve this equation as x equals a function of y, I'll just say good luck to you. It's not really going to work that well. And so what we have to do instead is the following. So I'll say that disk washer won't work. And really, we don't even have two different functions. This is in fact the same function forming both parts of the washer. Okay, and so what we have to do instead is, let's say we pick an x value here. Now, I can actually form a cylinder just like so. And so now the surface area of that cylinder is right over here. It's 2 pi rh. And you'll notice, well, let's just fill it in. That's 2 pi, and now r, well, the distance from the axis to the point here, x, looks to be just x units, right? So 2 pi x, which is my radius, and now the height is given by the function itself. So I think f of x. Okay. So this is our, I guess, quote-unquote cross-sectional surface area. And this should kind of make sense. I mean, given, I guess, the issues around toilet paper recently, the way that you get toilet paper, the way that the roll fills out is that you have these little tiny sheets that keep adding up, and then you get a full roll of toilet paper. And so that's essentially what we're going to be doing, is we're going to be having these little sheets that have surface area 2 pi x times f of x. And now if we add just a little bit of width to this, then you can actually find the volume of that like cylinder, but it's like just very, very thin. Like it's just only has a very little thickness to it. And so let's pretend that the thickness is called delta x. And then what we would do is we would integrate this, but what we know is that Greek turns to Roman when we integrate. And so for this function, the solution coming down here, the volume would be the integral, and now notice x is ranging from 0 to 2, so we're using the x bounds of the region. And we're just going to integrate this, but then this changes to a dx here. So we get 2 pi x f of x dx. Okay, and so this represents the distance from the axis, also called the radius, and this represents the height of sort of the cross-sectional cylinders that we get, right? So now it's just a matter of integrating this. So this is integral 0 to 2 pi x times, and now f of x, if we have to go back up here, is 2x squared minus x cubed. Dx. Okay. And we have some foiling to do here. We should distribute that out. Integral 0 to 2 pi 2x cubed minus x to the 4 dx. The antiderivative of which is x to the 4th over 2 minus x to the 5th over 5. Plug in 2, we get 2 to the 4th over 2 minus 2 to the 5th over 5. Right, so the common denominator, I guess, is 10. 2 to the 4th is 16. So multiply that by the 5 and you get 80. And now 2 to the 5th is 32. Multiply that by the 2, you get 64. So we get 16 in the numerator, and this 2 will cancel here with the factor of 2 in the 10. And so you get 16 pi over 5. All right, so just to recap, using shell method, the integral will be from the x bounds of the region when you have a vertical axis, and you get 2 pi radius times height. Okay, so we'll explore that a little bit more in the next video.